Hi everyone, and welcome back to Why Decrypted. And yes, for the first time, you get to see me on camera. The reason for this is that our new studio was meant to be ready today, but it isn't. So what we've got is this iffy CGI background, but hopefully that won't be too off-putting. So today we have another script by Ben, and we are looking at the time travel paradox you probably haven't heard of. And we have a new channel intro. I suppose I ought to do that then, Ben. So, welcome to Why Decrypted, the place where science, mystery, and a dash of the impossible collide, and where the universe never quite plays by the rules. Time travel. Few ideas grab our imagination quite like it. It's the ultimate fantasy, the chance to rewrite our past mistakes, cash in on future knowledge, or if you're Marty McFly, very nearly obliterate your own existence by accidentally becoming your mum's teenage crush. From H.G. Wells's time machine whisking Victorian gentlemen into a distant future, to Marvel's Avengers bouncing around the timeline like it's a pub crawl, we love the idea of bending time to our will. The past is a temptation, the future is an irresistible mystery. Right? But here's the catch. As much as pop culture makes time travel look like a clever plot device, physics has a very nasty habit of rolling its eyes and saying, nice try, but reality doesn't work that way. You see, there's a problem buried deep in the laws of the universe, and it's called a paradox. And the one we're exploring today, the time travel paradox you've probably never heard of, is both fascinating and infuriating. It goes by the intimidating name of the Novikov self-consistency principle. But don't panic, we're not going down into the equations. At its heart, this principle is basically the universe wagging its cosmic finger at us and saying, you can travel back in time if you like, just don't get any funny ideas about changing things. Because according to this rule, the past is stubborn. It's fixed. You might nudge it, but it will nudge back harder. Any attempt to alter history will only create the condition that guaranteed the thing you're trying to stop actually happens. Think of it like this. Imagine you spot yourself in the future spilling a cup of coffee. Being a heroic, coffee-loving traveller, you leap back in time to save that drink. You reach for the mug, but in doing so, you knock over a pen, which distracts you, causing, yep, you guessed it, the coffee to spill anyway. Congratulations, you've just been Novikoved. So here's the strange beauty of the Novikov self-consistency principle. It doesn't ban time travel outright. Unlike many killjoys in physics who wave their arms and say, impossible, Novikov basically shrugs and says, sure, time travel works, but the universe will always iron out the wrinkles to make sure nothing contradictory happens. And that's where it gets both fascinating and maddening. Because if you can travel back, then you're not really free to do what you like. You're part of the machinery. The timeline already knows what you did, or what you will do, and it's all locked in. Every little action you take is, in fact, the thing that ensures history plays out exactly as it's supposed to. You missed a word out there, Ben. That's what confused me. Take the famous grandfather paradox. You've heard of this one. If you went back in time and killed your grandfather before he had kids, you'd prevent your own existence, and therefore couldn't have gone back in to do the deed in the first place. Take the famous grandfather paradox. You've heard of this one. If you went back in time and killed your grandfather before he had kids, you'd prevent your own existence, and therefore couldn't have gone back to do the deed in the first place. Contradiction. But Novikov politely waves this away. In his version, you simply wouldn't be able to kill your grandfather, not because of morality or guilt, but because something somewhere would intervene. The gun would jam, you'd trip on a paving stone, or maybe, in a deliciously cruel twist, the person you thought was your grandfather wasn't actually him. In other words, the timeline protects itself. The past is like a stubborn old oak tree. You can shake the branches, but you can never move the trunk. Now, on the surface, this sounds like the universe is being unreasonably bossy. But think about it. If it didn't work this way, reality would unravel faster than England in a penalty shootout. Christ, Ben, that's a bit harsh. Um, 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 Ben, we've won the last two penalty shootouts. Ben's an American, ladies and gentlemen, so I don't know actually if he's into football or soccer, as you guys call it. What I do know, though, is that we have a wide decrypted fantasy league now, and we will drop the link for that in the comments below. So if you do want to join, please feel free to. Right, what was I doing before I got onto fantasy football? Every contradiction change would split logic apart. Cats would be dogs, causes wouldn't follow effect, and you'd be stuck in a metaphysical version of Inception, but without the cool music. So instead, the universe just says, fine, go back in time if you like, but whatever you do, you're only ever going to end up fulfilling history, not changing it. And this leads us to the absolute bonkers question. If you can't change the past, then what does free will actually mean in a universe with time travel? Because let's be honest, if you don't even have the choice to stop yourself spilling a cup of coffee, what does that say about whatever else we can do? Now, the grandfather paradox gets most of the airtime, but it's not the only game in town. Time travel is like a but. Oh, I struggled with. This is my second recording of this video because I did the first one as an audio one, and then we decided to do an audio visual one. And the first time I tried to record this paragraph, it took me about 10 goes as well. So I'm going to try again. Now, the grandfather paradox gets most of the airtime, but it's not the only game in town. Time travel is like a buffet of logical headaches, and the Novikov principle is the maitre d' politely insisting that you don't pile your plate too high. Take the bootstrap paradox. This one is delicious. Imagine you travel into the future, find a copy of Shakespeare's Hamlet, bring it back, and hand it to a young Will Shakespeare. He publishes it as his own work, and centuries later, you discover the same copy and take it back again. The question is, who actually wrote Hamlet? You, Shakespeare, or has the play simply existed in a timeless loop with no original author? That's a bootstrap paradox. Information or an object that exists without ever having been created. And under Novikov's rules, it's totally allowed. No contradictions, just a cosmic shrug. Or the predestination paradox, which is essentially destiny with a sci-fi twist. You go back in time to prevent a disaster, but your very actions become the cause of that disaster. Try to stop a war, you accidentally fire the first shot. Attempt to prevent a fire, you knock over a candle that starts it. In this model, the universe isn't just bossy, it has a wicked sense of irony. So far, we've been living on the land of thought experiments and spilled coffee. But what about the actual science? Does physics allow any of this? The answer is a tentative maybe. Ben, that's really tentative. Einstein's theory of general relativity doesn't outright ban time travel. In fact, the math predicts strange things called closed time-like curves. Loops in space-time that, in theory, let you return to your own past. Kurt Gödel, a logician best known for proving that maths itself is an incomplete, and Ben's put in brackets here, cheerful bloke, came up with a solution to Einstein's equations in 1949 that describes a rotating universe where time loops are possible. Then there's the Tipler cylinder. Imagine an infinite long rotating tube of super dense matter that twists space-time around it, creating potential time loops. And of course, everyone's favourite sci-fi trope, wormholes. If you could stabilize a wormhole and keep it open, something exotic like negative energy, and then accelerate one end close to the speed of light, you should, in theory, step through and arrive in the past. Simple, right? Just find some exotic matter lying around at Tesco's. Ben, do you have Tesco's in America? Actually, I'm not sure we have Tesco's where I live. Oh, yeah, we do. Yeah, there's a garage down the road. Yes, we do have Tesco's. But here's the kicker. Every time we cook up these solutions, the Novikov principle lurks in the background. Even if you manage to travel back, the paradox police show up and say, fine, but you're not changing squat. And many physicists argue that once you factor in quantum mechanics, the weird probabilistic rules of a microscopic world, paradoxes might simply cancel themselves out. Reality doesn't like contradiction, so it engages and engineers events in a way that always preserves consistency, like a cosmic spell checker correcting your attempt to mess with the timeline. Here's where it gets uncomfortable. If the Novikov principle is true, then free will, at least, when it comes to the time travel, might be an illusion. Think about it. You step back to stop yourself from spilling coffee. You think you're making a choice, but every possible path you take still ends up with the same result. The coffee spills because the timeline demands it. Philosophers have been arguing about determination for centuries. And are we truly free, or is everything we do an inevitable consequence of prior events? Time travel paradox is poor petrol on that fire. It's going back. If going back doesn't change anything, does that mean our lives are already set in stone? Some people find this depressing. Others find it strangely comforting. If the universe has already written the script, maybe your mistakes were inevitable. Your triumph's guaranteed. You're not failing. You're just playing the role in a cosmic story. But then again, who likes being told they're just a character in someone else's novel? Especially if the author has a cruel sense of humour. Alright, so let's have some fun. Suppose you travel back to assassinate Hitler. Oh, Ben, do we have to use that name? That's going to do this video the world good. The classic thought experiment. Under Novikov, you simply couldn't succeed. Your gun misfires, you get lost on the way to the rally, or plot twist, you take the wrong man out entirely, and history carries on unchanged. The war still happens, the atrocities still occur. Chilling, yes. Consistent, also yes. I visited Auschwitz earlier this year. It was a very moving and poignant experience. This is supposed to be light and fun. Let's go on with it. Okay, let's say you went to make some. Okay, let's say you want to make some easy money. You go back a week, armed with the lottery numbers. You place your bet, smugly confident, but then you lose the ticket, or the numbers mysteriously change, or someone else wins under bizarre circumstances. Your attempt to catch him becomes the very reason you never profit. Even meeting yourself, the holy grail of time travel weirdness, would play by these rules. You could do it, sure, but whatever conversation you had would only be the one you were always meant to have, awkward small talk included. It's like the universe is playing chess, and no matter how clever you move, the board always resets to checkmate. You can try to outwit fate, but fate has already read your playbook. So where does this leave us? The Novikov self-consistency principle doesn't kill the dream of time travel. It just makes it less fun. Instead of wild adventures where you change history and reshape the future, you're left with a locked-in loop where your actions are always part of the story, no free will, no do-overs, no cheating fate. And yet there's something oddly poetic about it. Maybe the universe is wiser than us. Maybe it knows that giving us the power to rewrite history would unravel everything. So instead it lets us play, but only inside the lines. So here's the big question for you. Knowing all this, would you still step back in time? Would you risk meddling with a stubborn universe that always wins? Or would you leave the timeline alone? Sip your coffee and let the pen fall where it may. That's a good question, Ben. I think I would go back and still have a go at changing history. In fact, I'd like to just go back and observe some of it, to be honest. Right, everyone, that's the end of the script. So, massive thank you to Ben, and thank you for making it much shorter than the last one. I hope you've enjoyed this. I hope seeing me on camera with this dodgy background isn't too off-putting. Until next time, this has been Why Decrypted, where nothing is quite what it seems.